Hello everyone, and welcome to this theory recording on the step response of RL circuits. So similar to the RC circuit, we know that you have a first order differential circuit because of the presence of the inductor. IL is equals to L di dt, first order expression. And we know that the step response will occur when a source is suddenly introduced such that there is a forced response as well as a natural response. The current response is what we're interested in. Again, we're dealing with an inductor and we want the current IL that's flowing through that inductor. So the current response is what we are interested in. Now, with the step response of an RL circuit, again, there would be a similar expression, which this time we're not going to go through, but effectively what we would be doing is we would be doing an expression of KVL flowing through the circuit. So we would basically say minus Vs plus the voltage over the resistor, which would be IR, plus the voltage of the inductor will give you 0. So minus Vs plus IR plus L di dt gives you 0. And you would then simplify this expression. You use the Lenz's simplifications to a point where you're going to get an expression that says the current IT gives you 0 when t is smaller than 0, and gives you I infinity in the final current plus I0 minus I infinity e to the minus t over tau for when t is greater than 0. So again, I don't emphasize on the derivation because typically you are asked to use the expression rather than to derive it. Right, and the procedure, step 1, determine the initial and final conditions. So the initial conditions, I at t equal to 0 negative is going to give you I at t is equal to 0 positive, which gives you I0. And the final conditions will be I infinity. So we know that at time t is equals to infinity, the inductor must become a short circuit, and then we need to get the current I infinity flowing through the short circuit. Second, we need to get the time constant. We'll remember that tau is equals to L over R, which is L equivalent over RTH when t is greater than 0. And then we determine the final current response. So the current response as a function of time is going to give you I infinity plus I0 minus I infinity e to the negative t over tau amps. And this is obviously when t is greater than 0. So determine your initial conditions, determine your time constant, and then you plug it into the current expression to get the current value when t is greater than 0. Thank you for watching this video and enjoy the course.